Hey everyone, welcome to my channel. Today we are going to create this Pong game, which I call as the Forever Alone Pong game because you can play it by yourself without needing a second person. So this is quite a lot of fun to play around with. And as you know, most of the programmers, they are pretty much alone. So this is applicable to 90% of the programmers out there. So they will enjoy this and it is a lot of fun to create as well. So you will learn step by step how do we create this. And as you can see, the game gets over if it passes one of the bats, and you can press the R button to restart the game. And you can also see that at the bottom you have our main webcam feed as well, and you have the score on the sides. And when the game ends, it shows you the total score because, frankly, it was just you playing all along. So this is a lot of fun. So stay tuned and we will go through every step and how to build this. If you would like to level up your computer vision skills, do check out our premium courses that are available on our CV Zone platform. Links are in the description. So without further ado, let's get started. Before we begin, I would like to mention today's sponsor who are giving away $50 credits for 8 people. And all you have to do is you have to comment below what project would you like me to build next. It should be a computer vision project. And whoever gets the most likes will be automatically in the loop. And we will pick the 8 highest ones from the comments below, and they will be getting $50 credits so that you can use those credits to build your prototypes for your PCB designs and create the products that you have come up with. So before we begin, let's check out their facility, which is pretty amazing. So have a look and we will start with our project. Today's video is sponsored by JLC PCB. JLC PCB provides high quality production of your custom PCB designs. They have their own factories with fully automated production lines to provide high quality and consistency that is used by over 800,000 businesses and innovators. Their fast and reliable service, along with 24-hour customer support, makes it an ideal choice for rapid prototyping of your ideas. Simply add your Gerber file to their website and select the desired parameters and see the magic happen. So visit their website and order your PCBs today. So now let's go ahead and start with our project. Today what we are building, as you know, is the Pong game. So we have a project here by the name Pong, and what we are doing is we are first of all going to go to settings, and we are going to go to Pong, which is the project name. We'll go to the Python interpreter and add our packages. So we will be using OpenCV for this, and we have a wrapper for that, which is CV Zone, and we also have some other functionality within it. So for example, we can import PNG images without writing a lot of code. We also can use hand tracking module without writing a lot of code. So that is why we are importing this. And we will also import media pipe, which will allow us to import the Google packages for the hand tracking and the pose estimation and a lot more. But for this project, we are just going to use the hand tracking module. So I believe that is pretty much it. Both of them are installed. And now we can go ahead and move on to our main project. So the first thing we have to do is to import CV2, import CV2, and then we will also import the CV zone package. And in fact, yeah, let's import that. And we will also import from CV zone dot hand tracking module. We are going to import the hand detector. So this will allow us to detect our hand, move around, and so forth. So before we begin, we are going to import all our assets, all the resources that we require to create this project. So we will create a new directory for it so that it is a little bit more organized. So we will write here resources. Did I write the spellings right? I think it's wrong. Let's open that up. Yeah, the spellings are wrong. So it should be resources. There you go. So now we have our resources, we have our virtual environment, we have our main file. Actually, we didn't add anything to it. So let me copy all of that. There you go. So if we open that up, here are the items that we will be requiring. We'll have a background. So this is the background image. We are going to use add weighted function to actually blend in the background and this image so that we can see something, what is going on in the background as well. So we'll be moving and we'll be able to see ourselves. Then we have the ball. The ball is very small. It's 50 by 50. And this is a PNG image, which means that we will have the edges as well. So we will be able to differentiate between the edge of the ball and the background. So it has the transparency element. Then we have the bat. So I'm calling it the bat. You want to call it anything else, you can call it that. So this is the design that I came up with. You can design whatever you want. One of them is the red color, the other one is green. And this is what we're doing. And then we also have the game over. And this will be just an image. We are going to overlay it at the end. And we will show the score over here. And we also have the information that you can press R to restart the game. So that's the basic idea. So these are the resources that we require. We are going to close it. And as you can see, they are over here in our resources folder. So let's go ahead and open up our webcam. So that will be the main image that we are going to start off with. Then we will overlay another image on it. Then we will add the bat and so on. So let's go ahead and we will write here cap equals cv2 dot video capture. And we are going to capture the device number 0, which is by default. Now, most cameras, they will have 640 by 480 resolution by default, but we don't want that. We want a bigger area for playing because we have 2 fingers, 2 hands that are playing the game. So we want a little bit bigger area. So we will say that the prop ID number 3, which is your width, is 1280, and the prop ID number 4, which is the height, is 720. So these are our parameters. And then we will simply say while true, we are going to write that underscore means you can ignore. Basically, that's the success. It's a Boolean, whether it is able to get the frame or not. And then we have the image, which will be our frame. And then we will write cap.read. So that is pretty much it. Then we will write cv2.imshow. We are going to write in our image. So let's call it image. And which image are we going to display? img. That is what we are going to display. And then we will write cv2 dot wait key, and we will give it 1 millisecond delay so that we can actually see the result. So let's go ahead and test it out. So let's run it, and this will open up my webcam. So you will see, here you go. We have a big area where we can play. Should be like this. There you go. So we have this big area. We can do this at the end of the day. So we'll be able to play around with that. So far, everything seems to be good. Next step is to overlay our image. So we will create this space in between, which is basically the area in which we are going to write pretty much most of our code. So here we should write some comments. So we will write here, the first thing is we are overlaying the background image. So that's the first step. So how can you do that? You can do that by cv2 dot add weighted, but we did not import any images yet. So what we need to do is we need to import all the images that we are going to use later on. So let's just do it now. So in the resources, you will see we have background, we have ball, we have bat1, bat2, game over. So we are going to import all of them. So here, let's just write that this is importing all images. And we are going to write that our image background equals cv2.imread. And we are going to give in the link of the image. So here it will be background. No, actually it will be in resources slash background.png. Now this is a normal image and we are going to use it normally. So there's nothing fancy about it. So we will keep it like this. Now the other images that we are going to import, for example, the ball, we need to remove the transparency from them. So that is, you can say it's a little bit of a fancy trick that we have to play. So what we will do is we will import it and we will give in a flag. We will give in a parameter, which will be cv2.imread unchanged. So we don't want you to do any processing on this. Just import the image, have the alpha channel, have the transparency so that we can play around with it. Otherwise, we won't be able to do that. Okay, so the same thing, actually, I need to change that. Background will be ball.png. So the same thing, we will apply it on the bat and bat, let's say bat 1 and bat 2, and then we have the image game over. Actually, image game over is pretty much the same as the background image. So we don't need to add the transparency for that. So we can remove this part. So here we can write, what is the name? Game over. And then we have the bat.png. Bat, is it small? Yeah, bat.png. Then bat1. Oh, it was ball. Where is my head? So this one is ball.png. Okay, this one is bat1.png, and this one is bat2.png. There you go. So we have imported all the images, and now we are going to import them, or better yet, use them. Okay, so we will write here image. So that is one of the images, and we'll give the alpha. So the alpha, this is our main image. Let's put it at 0.2 so you can see. Later on, we'll make it 0.1. And the source, the second source is basically your image background. And this should be 1 minus 0.2. Whatever value you put here, it should be the negative of that. So here it should be 0.8. So adding them should give you 1. And then we'll give gamma as 0. We don't care about gamma. Sorry. So then we have the image and the background, and we are going to put it back. Now you can put it to another image. You can call it image output, or you can just keep it one, same image. So we are lazy. We're going to keep it. Okay, so let's run that and let's see what happens. There you go. So now you can see me in the background, and if I move my hand, you can see me as well. So what I like to do is I like to keep it very light so that the game is more visible and you can see what is happening. And in fact, you can put it as 0.05 and 95 as well. So here you can still see me. But for the most part, I'm going to put it as 0.2 so that you can see me better, what is happening. And then at the end of the game, if you want to change it back to 0.1 and 0.9, that's fine. And I think that's what we'll do at the end. So that's good. Okay. So what's the next step? The next step is to add or use the hand tracking module. Now, at any given point, if we have made any changes to the CV zone package, or you don't know how to do it, you can click on the control button, and then you can click on hand detector. So this will take you to the code, to the actual code, the module, and at the end you will see that there is a main function. And in this main function, you will see an example of how to use the code. So how to use this module. So this will be the latest one. So if there is any changes, any upgrades, this is definitely upgraded. So if you want to use, if you don't remember how to use it, and if you want to use it, then that is the point where you should look. So here, the first thing is you add a detector. So we'll copy this part and we'll paste it above the while loop, because this will happen only once. So we will write here hand detector, and we will create a detector and we will call it hand detector. We'll use the class hand detector. And then within that, we are going to say the confidence is 0.8, the hand confidence, and we are going to add 2 hands as the maximum. Don't try to detect third hand if there is. So that's the idea. And then we'll go to the hand tracking, and then here is the part where you're getting the image. We are doing the same thing. Then we are applying the hand detector on our image. So we will copy that, and we are going to go back, and here, after we detect the image, we are going to put the find hand and its landmarks. So this will automatically draw the hands that it has found on our image. And yeah, that's pretty much it. So if we run it, now we should have our hand. Now this is why we use CV zone. Otherwise, you could use media pipe. but then you have to denormalize the values. You have to extract all the values one by one, and um, it is a bit of a process that you have to go through. Anyway, so these are our hands, but the problem is this is my right hand, but right now it is in the right position, but it is showing in the left, and the left is in the right position. So it is confusing. If you're playing the game, it will be confusing. So what we will do is, here we are going to flip the image. So we'll say image equals cv2 dot flip, and we want to flip our image, and we want to flip it in the horizontal direction, and which has the ID 1. And if you put 0, it will flip in the vertical direction. This one is horizontal, so we will use 1. And once we flip that, the image will flip and it will work well. But the problem is, we will have the wrong hand detection. So this one is not left. This one is my right hand, but it is showing left. And this one is my left hand and it's showing right. So this is not acceptable. So what we will do, we have a function in our CV zone. Sorry, we have a flag in the CV zone, and we call it flip type. Flip type, we will put it as false, and this will solve the issue. So but basically what this means is, by default, we are flipping the image. So we are telling CV zone, don't flip the image. So this is what it. Okay, so let's check that out. So this is my right hand and it's showing right. You can see here at the top it says right. And this is my left hand, and it's showing here that this is the left. Is it clearly visible? Yeah, it is visible. Okay, so there you go. So these are our hands. We are going to use them. Now, if you want to remove these, what do you call the drawings, you can do that too. And you can write here, draw is false. But in that case, you have to remove this image. So it will not output the image. So let's run that. This time around, it is detecting everything is working, but it's not showing you the detections. But because we are learning, I think it's better to keep it simple. We will actually show it and draw it on our main image. So we know everything is working fine, everything is going good. Okay, so far it's well and good. The next step would be to add our bat and the ball. So to add the bat, you have to use the what do you call, the hands, the detection of the hand. But to add the ball, you don't need that. So what we will do, actually, let's put this. Okay, let's put it like this. And then here at the bottom, at the end, we are going to add the ball after all the calculations and everything. So we will write here, draw the ball. Okay, now normally this is a little bit of a difficult process and a long process if you want to overlay a PNG on an image in OpenCV. But we have a CV zone function for it, and it is very simple. What we have to do is we have to use the image overlay. So we'll write here CV zone dot overlay PNG. And what we have to do is we have to give in the image background. So our image background is basically image. So that's our main image on which we want to overlay. And what exactly do we want to overlay? That is our ball image. So we will give in our ball image. So we'll write here image ball. And then we have to give in the position. So for starting, we'll just give in, let's say 100, 100, random value. You can give in any other values that you want. And of course, it will return us something. So we will write here image equals this. So we will put it back all in our image and put it to the final result. So let's go ahead and see that. So image front shape, object has no attribute shape. Ooh, that is interesting. Did we import that? Image ball. Oh, that is the problem. There's two .pngs. So now it should work, and there you go. So this is the ball, and it will start with this position, and then it will move around, and we can play with this. So that is good so far. So what should we do next? Should we move it? or should we bring in the bats? If we move it and we are drawing it, it will go out of the image and then it will give an error. So let's do that at the end. Let's bring in the bat first. So how do you do that? After overlaying the image, we are going to check for the reason I'm writing all of these comments is because during learning you can forget, oh, what did I do, why is this line for, what is that for, but normally you don't write that much comments. But don't just focus on writing good code with good variable names and assume that that's enough. No, people sometimes, like the hardcore programmers, they will tell you, no, 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 don't write any comments are bad, your code should explain itself. No, that's not true. Write comments, but don't overdo it. Okay, so anyways, check for what are we checking for? Check for the hands. So if we have the hands, we will say if hands, and then we are going to put that we need to check if the hand type is left or right, and based on that we will put our bat on the left and right. So we will say that we need to loop through all the hands. For hand in hands, we will loop through all the hands, and then we will check if the hand type hand, how do we check that? Yeah, we check it by, it's a dictionary, so you can write here type. If that hand type equals left, then we are going to put the bat on the left side. Now, how do you put the bat? It's pretty much the same thing. We are going to overlay a PNG and we can just paste it here, and we will put it on the image back. Yes. We want to put it on the image. Yes. We don't want to put it the image ball. We want to put image bat 1. And this is the position 100, 100. So let's just put it 50, 100 and let's run it. So because we just want to see whether it's working so far or not, and then we can add more. So if I bring in my right hand, nothing should happen. But if I bring in my left hand, you see the bat is there. So that's what we need. But you can see the position is wrong. And I think I checked it before. The position is 59. So the X value is 59. So if we bring that in, it should be within that region. So we have created these regions, as you can see, and we will slide it within that. It will look very good. So we will go up and down here. So that's for the slide. And now for the the Y value, that should be coming from the hand itself. So what we need to do is we need to get the value of that hand. So here we are going to type in that our X, Y, and width and height are equal to the hand. And again, it's a dictionary, so we have the bounding box information. Now you might be thinking, wait, how do you know this? If it's a dictionary, and how do you know that this is that value, this is that value? How do you know that? So if you want to know that, it's very simple. You click on, let's say the find hands. You click control and you click on find hands. You go to that function or you go to that method, because it's in a class, you call it a method. And there you can see you are putting this in the dictionary, my list, LM list, bounding box, center position, left, right, like this is the type. So all of this is going into your list. So these are the dictionary values that you can use. These are called the keys. So these are the keys that you can use. So here we are using the bounding box key, and it will give us these values. Then we need to decide on the width and the heights. And what we need to do is, first of all, our width, let's call it width 1, is the same for both the images. Is it same or no? It is going to change. So the width, the starting width is 59 over here. That's correct. But the width of the image is what? So let's go to the bat. Here you can see on the top right, the width is 26 and the height is 129. I hope you can see that. So it is 26. So we will write here W1 is 26. That's our value. So that's the value of the width. And then our height, h1 is 129. Now you could do it dynamically. You can get the values from the image from the bat. You can do a dot shape as well. So for example, you can write here um, image bat dot shape, and then this will be h1 and w1, and then the last one is the channels. So these are three channels. We don't care about those. So you can do it dynamically like this as well. So once you get the shape, and then you will need the height. So this is the main thing that we want to use. So it should go up and down, up and down. So we need to know what is the height at this point. So the height, we will call it y1. So y1 is basically equal to the current y, so the starting position of the y, minus, we are going to shift it in the center of the image. We don't want to move based on the top of the image. So let me show you here. We don't want our finger to be here. We want our finger to be here in the middle. So we will take its height, we will add it to our height value. Sorry, subtract it. So height minus the current value minus height 1 divided by 2. So this will give us our center position of that y value. So here now we can just put it here as y1. That's it. So if we run that, let's run that and the left one. So there you go. So if I go up, it goes up. Oh, 1 too far. I'll tell you how to fix that, but let's just check this out first. So we are here, we go up, we go down. Now we should not go below this. And there is a reason why I have kept this purple area, because if you go below this, the detection is bad. You can see it flickers because the hand is not completely in the image. So it flickers and it's bad. So that's why we will just use it from here onwards, from here till the top. So what we need to do is we need to clip these values. So this is the maximum and this is the minimum. Because if you see, if I go above that, it gives an error. It says, I cannot draw this because it's going out of the image. So to clip this, we can use NumPy. We already have installed NumPy when we were installing CVZone. So we can simply say import NumPy as NP. So once we have that, we can use the clip method for NumPy. And we can clip it here. So we will say that our y1 equals numpy.clip. And what is the minimum and the maximum value? We want to clip y1, by the way. We need to write that first. And then the minimum and the maximum value. So the minimum value I checked earlier, it is 20, and the maximum is 415. So that's how much you should clip it. Now this doesn't matter if it's the left hand or the right hand. It's the same for both because the height is the same for both. So let's try that. There you go. So if I go up, it clips. If I go down, it clips. There you go. It clips. It doesn't go below that. Even if I go, it doesn't go below that. So that's perfect. So this is our left one. And yeah, so let's do the second one, which is the right one. We will copy all of this. And we will say if the type is right, we want the image bat to, and this value will be, what is this value? This value will be 1195. Again, I have done this by trial and error. You can go ahead and do this if you don't like to add direct values. There you go. So if I bring the right one, there you go. It is already clipped because that is before the if statement. And there you go. No, there you go. So if somebody sees me like from outside, this will look very weird. What am I trying to do? But if you see the result, then yeah, it makes sense. What am I trying to do? That's good. So that is good. And the next thing we need to do is we need to check the ball. Now we need to move the ball. And based on the ball position, we are going to check whether it hits something or not. So the first thing we'll do, we will move the ball. So here we are going to write move the ball. And moving the ball is very simple. It's extremely simple. all you have to do is you have to tell them all to change its position. So what we can do is we can declare here, let's call it variables. Spellings are wrong. Variables. And then what is the variable? It's the ball position. So the ball position by default, let's keep it at 0, 0. So that's the default position. Or no, we kept it at 100, 100. So let's keep it at 100, 100. And then we will go down, and instead of this, we will write here ball position. There you go. So this is the ball position now. And now we can keep changing these positions. So we will say ball position plus equals a speed for X, let's say, speed X. And this one is the 0 position. So this is the X value of the speed, and this is the Y value of the speed. So we'll write here Y, and we need to declare X and Y. So speed, the reason we are writing it as a variable is because we need to change it, and we can increase it as well. We will not do it now, but later on, if you wanted to, you could do that as well. So as you progress through the game, it will become harder and harder. So let's put it as 15, and speed Y equals 15 as well. So yeah, that should be good. Let's run it. And there you go. So the ball moves, goes directly down, and the game is over. Well, it gives an error. So let's just slow it down so that it's easier for us to see what's happening. So there you go. The ball is moving. I can do this, but nothing happens. So the ball goes down, and boom, it hits it. So that's not good. So the next step is basically we need to tell the ball to bounce off the walls. So the first one is the up and down, so the vertical walls. So we need to tell those, horizontal walls. We need to hit those, and then we need to bounce off them. So how can you do that? It might seem a little bit complicated, but it's not. It's very simple. So before we actually give in the speed, we are going to check if ball position at 0 is greater than or equal to, let's say, no, this one, this one is 1, not because we're talking about the Y, not the X. So if this is greater than 500, so the 500, I think, yeah, 500 is a threshold, the below threshold, or the same thing is less than, ball position is less than or equal to, what is the value? 10. So if that is the case, change the Y direction. That's it. So whatever the speed is, whatever speed Y is, just make it equal to minus speed Y. That's it. That's how simple it is. That's how you change the direction. So let's run that. Why didn't it? Okay. So now the bouncing should be there, and it will look very exciting. So fingers crossed, boom, bounced. Let's check the one above, boom, bounced. But then it goes there and everything is gone. The game is over. So that is good so far. And again, I have done this by trial and error, these values. So you can check whether these values, if you change the design or something, you can change these over here. So that is good. So the next step, what should be the next step? Let me check. The next step actually should be to check whether the ball is hit or not, whether the bat is hitting the ball. If it is, then we need to count, we need to add the score, we need to check when the game is over, and so forth. So, but that we can check only when one of the hands are present. Okay, so we will check for each hand whether it is hitting the bat or not. And again, it is just an if statement to check whether the ball is hitting or not. So the if statement is as follows. If the starting point, if, or let's write it like this, if the ball position at 0, okay, so if this position is in between the bat area, so the bat area, if you know, starts at 59. So it starts at 59 and it ends at 59 plus the width of the bat. So the width of the bat is W1, which is 26, I believe. Yeah. So it will be 59 plus 26. Or let's write W1. Right? So if it is in between that region, so it means it has hit the bat. But we need to check the Y as well, not just the X. So we need to check whether you are in that Y region as well. So we will check and the ball position at 1 should be in between the Y value. So the Y value here, this is the starting position. So we will write here, this is Y1. And then the ending position will be Y1 plus the height of the bat. The height of the bat is 129, which is also H1. So we can just write here H1. If that is the case, it means it has hit the bat. Then we are going to reverse the direction of the X. So earlier we reversed the direction of the Y. Now we simply reverse the X, which is like this. So you'll say speed X equals minus speed X. That's it. And that's how simple it is. And we can do the same thing for the other one. We can copy this part. And instead of 59, you will put 1195 and 1195. And the rest is pretty much the same. So let's run that and see if it works. So now it should be able to hit the bat. And I will tell you there's an issue as well. This is too slow, by the way. You need to increase the speed. Come on. Waiting. Ah, it hit. But let's just speed it up. Speed it 15. So yeah, there you go. It's hitting a little bit at the back. This one is fine. This one is, yeah, it's a little bit, the starting point doesn't seem right. What is the starting point? 1195. Let's put minus 50 and 1195 plus width. Let's just remove that. Yeah. Okay. Oh, you see that bouncing? We are going to fix that as well. How can we fix that is simply giving it a little bit of a push in the X direction. So you can write here that the ball position at the X value plus equals, so this one will be plus or minus. Yeah, this one will be plus. It will be plus 30 and this one will be minus 30. Now what this will do is it will just suddenly move the ball a little bit forward and it will give the illusion that it suddenly hit something. It hit the bat. Plus it will allow us to avoid that bouncy as well. Okay, by the way, this should be 195. And we can reduce that value as well. So minus 30 maybe, let's say. So the bouncing, again, we can fix it like this as well. Oh, nothing happened. Why is that? Let's try it again. Yeah, there you go. There you go. No. So it should not be at the top. It should be in the middle somewhere. So for it to hit properly. So yeah, that's good. I believe that should be good enough. But now the problem is coming whenever it goes outside the range, it gives an error. It shuts down the system. So what we will do is we will write here a flag and we will call it game over, and we will put it as false. So once we have that as false, we are going to go down, and at the end we are going to check for the game over. So after we are checking for the ball position, or let's just check it over here. So this should be outside the hand statement, so not inside the if hand statement. So here we will check for the game over. So we will write if the ball position at 0 is less than, let's say, 40, because at 59 is our bat. So if it's before that, it means we didn't hit and it's already over. Or the ball position at 0 is above this value 1995. So let's say 1200. If it's that, then we will write game over equals true. And if game over is true, then we are going to write, or should we use that? Yeah, we need other flags. So we will write here if game over equals, or let's just put it like this, if game over, we are going to say our image is basically image game over. And we need to put some text as well. We can put that later on. But yeah, so in that case, it will be game over, else you do this, else you move the ball. Don't move the ball if the game is over. That's the basic idea. Game over, and here we can write if game not over, move the ball. Simple as that. So yeah, but we need to draw the ball. Do we need to draw the ball? You don't need to draw the ball if it's game over. So let's just push that in as well. So yeah, let's see if it now, if it goes out of range, what does it do? Does it game over, or does it still run or give an error? Let's try that. There you go. Still doesn't work. It didn't work at all. Why is that? So what's the issue? Wait, this should have worked. Image. It's saying there's no image. Why is that? We have the image here. We have the background. Yeah, that should be fine. But it didn't stop. So if game over, image equals game over, that's correct. Else, move the ball. Yeah. Maybe this is wrong. Ball position is, let me check, ball position is less than 40, and ball position is greater than 1200, then game is over. Let's just print it out. Print game over. So every iteration will print game over, and we'll see whether it's detecting it or not. False, false, false. True. Wait, it detected true. Before that, it gave an error. Something wrong with image game over. Yeah, come on. I did the same mistake twice. We need to remove the extra.png. I don't know why. Anyways, so hopefully now it should end. There you go. So game over. And now we need to display the score over here. So whatever value we had, we need to add it here. But we don't have the score yet, so we need to add that too. So let's go ahead and write here score equals 0. So we have two scores, one for the left and one for the right. So we need to add both of them. So we will write here 0, 0. And whenever the left one has a score, we will write score at 0 plus equals 1, and we will copy that and paste it here, and we will write that score 1 is plus equals 1. So yeah, that should be good. And but we didn't display the scores, by the way, so we should display it if the game is not over. So we should display it here. So let's just put it at the end. So cv2 dot put text, we'll put it on our image. The text will be simply it will be a string converted from, what's the name of it, score at 0. And yeah, that should be it. And then we'll put the origin. Let me check the origin. The origin will be 300 and 650. Then the font will be cv2 dot font Hershey complex, and the thickness, the scale will be 3. The color will be white because it's above the purple color, so it will look good. And then we will have the thickness as 5. If you want to have a clear text relatively, then add the thickness more than the scale. Otherwise, it looks really bad. I don't know why, but it looks bad. So this will be score number 2. We'll put it as 1. And this value 300 will change. 650 will remain same. So we'll make it 900. And yeah, that's pretty much it. So let's run that and see if it works. There you go. So we have the score. We hit 1. And there you go. 1. There you go. Can move up, and there you go. So now the game over, when that occurs, we did not add the text. So that is what we are going to do. We are going to copy this. We'll go up here, and if game over, we are going to put the score here. And actually, the score we can put as, both. Just add the score together. Just make the person feel better. Okay, you scored that much, against yourself. So that's the idea. And we will give in the value as the 585 and 360. Now, one thing is that if the score is 1 digit, it will be on the left. If the score is double digit, it will be on the right. So it doesn't look very good. So one thing to improve that, what you can do is you can use zfill dot zfill, and that will add zeros before the value. If it's 1, 2, 3, 4, it will make it 0, 1, 0, 2, 0, 3, and so on. So let's put it as 2. So that the center is always correct when it's displaying the game over. Is the scale same? No, the scale is different and the color is different. So it's 200, 0 and 200. And then you have 2.5, and then you have 5. Let's check that out. This we can remove. I want that. There you go. Oh, the color is blue. Why? Oh, it's 20. Make it 200. Okay, let's run that. There you go. And game over. And there you go. So that's your score. So, and it also says that there's an option to restart by pressing R, but we didn't add that functionality yet. So that's what we are going to do. And that's very simple. You will go down here. You will put this in a key, and you will write if key equals ORD, and we will put R. And if that is the case, then we need to reset. So how do you reset? Yeah, you just copy all of this. That's how you reset. Paste it here. Anything else? And yeah, we need to import our game over image again, because it already has the text from our previous image, and it will overwrite on that, and it will not look good. So we need to paste it here. We need to import the game over again. So yeah, that is pretty much it. There you go. And if we press R, it restarts the game and we can play again. Now, one addition that you can do is you can add a little bit of a small image at the bottom left corner. And what this will do is it will let you see properly, like, okay, this is a computer vision game. There is a webcam running and all that. So how you can do that, right before you send the final image, you can write here image at, let's say, what is the height value? It is 580. Start from 580 till 700, I believe. It's 700. Let me check. Yeah, still 700. And then for the X value, we are basically cropping the image. So the X value will be 220 and 233. So that we are going to put from cv2.resize, and we are going to resize our image raw. But we didn't declare it yet. We are going to declare it now. We will put this as 213 and 160. So this is the size of our image. So the image raw is basically a copy of our original image. That's it. So here we are going to write image raw equals image dot copy. There you go. That's it. So if we run this now, we should have an image at the bottom showing us the actual webcam feed. Okay, we made a mistake. 213, 160. This is 2, 3, 5, 80, 700. Seems fine to me. Image raw is image raw. Actually, we should do it after this. So, yeah. Not sure where the problem is. 580 and 700. Let's try it one more time. Oh, it's 120, my bad. So this is supposed to be 120, not 160. There you go. So on the left hand side now you can see the webcam feed as well, so which is useful. So we can press R, and now we can play the game. 1 point. I need 2 points. There you go. 2 points, 3 points, and let's just move it, and there you go. Your score is 3 and the game is over. You can press R to restart and it will work well as well. So this was our game for the Forever Alone Pong game. If you would like to learn lots of different games, how to create using Pygame and OpenCV and using PyCharm, then do check out our Computer Vision with Game Development course. Over there, we are going to use physics. We are going to use a lot of different images, sounds, animations. We will look at how we can create games, and we can create standalone applications or standalone files that we can distribute for any computer, whether it be Mac or Windows. So you can learn all of that using our game development course. So do check that out. We go line by line and explain every single line of the code and how exactly all of these games are made. And we created games like Fruit Ninja, Balloon Pop, and a lot more in that course. So if you like to develop games, do check that out. If you like to build games like this, and don't forget to write the comments below, which game should I create next, which project should I create next, so that you can win the $50 credits for the JLC PCB as well. So you will be able to create your own PCB designs. They will manufacture it and send it to you right next to your home. So this is it for today's video. I hope you have enjoyed it. I hope you have learned something new. If you liked it, give it a thumbs up, share it with your friends, and I will see you in the next one.